In order to be more precise in the way that we talk about probabilities, we are going to look at a definition in mathematics called a set. A set is a way of talking about a collection of things. So for example, we might want to think about the collection of numbers from 1 to 6. Okay, so I could describe this collection of numbers as a set. I'm going to call this set A. We usually use capital letters. And when we write down what a set is, we use these curly brackets to describe it. So I'm going to put one at the end, but I'm not going to put the second one in just yet. If I'm talking about the numbers from 1 to 6, I could describe this as the set A, where the set contains 1, 2, 3, 4, 5, and 6. This would be the set of numbers from 1 to 6. Now, when we're dealing with sets, we can, or if we're thinking about this particular set, the numbers between 1 and 6, we can start to think about other collections of these particular numbers. So we could think of what we call a subset of this group. So imagine we were thinking of a subset. Subset is just a way of saying a collection of some of these elements here. So if I was thinking about the even numbers from 1 to 6, well, that set would be the numbers 2, 4, and 6. Or alternatively, I could think of a different subset. Let's say the numbers are greater than or equal to 4 from within A. This would be another subset, 4, 5, and 6. So these two sets here, B and C, are subsets of A because they're a collection of some of the numbers in that larger set. Now that we've defined what sets are, we can start to think about how we can work with them and what kinds of operations we might want to define on them. We're going to think about the two sets that we just talked about, the set of the even numbers less than 6, and we're going to think about the set of numbers greater than or equal to 4. And we're going to talk about two things that we sometimes talk about with sets, what we call the union of two sets and the intersection of two sets. The union of two sets is when we combine two sets together. So in this case, we're combining the set B and the set C together. And the way I write that I'm going to do that is I'm going to do a B and then a little, it looks like a little U shape, B-U-C. We read this B union of C. And the union is if we put all of those two sets together and we write out the full list of elements that are in one of those sets. So 2 is in B, 4 is in both of the sets, 5 is in C, so it's also in the union, and 6 is in both the sets. Notice that we don't list elements twice just because they appear in both sets. We only list them the once. So we say the union of these two sets would be the set 2, 4, 5, 6. I'll just write that is the union, not the intersection. When we're talking about the intersection, we write it with this symbol around the other way. The intersection is a way of talking about the set that contains all the elements that are common to both of them. So if we have a look here, both sets have a 4 in it, both sets have a 6 in it. So the union of these two sets would be the set 4 and 6. Okay, so this is actually a much smaller set. This is the intersection of the two. So it's important that we understand what this union and what this intersection means because it's going to have really important applications to the probability work that we're going to be doing. Another way to think about this union and this intersection is to use a Venn diagram. So what I've got here is this box. In this box we're going to put all of the numbers from 1 to 6. And inside we're going to have two circles. One circle represents the set B that we have here, and one circle represents the set C that we have here. If you remember on the last slide, we called the numbers 1 to 6 the set A. So everything here is inside A. They're all numbers between 1 and 6. Some of the numbers are going to be in this region, which is numbers that are only in B and not in C. Some of them are going to be here, numbers that are in C but not in B. And some numbers are in both B and C. So if we look through this list, the number 1, okay, it's not in any of these sets, so it's going to live outside those sets. Put it anywhere in here, I'll just happen to draw it there. 2 is in B, but it's not in C, so we put 2 here. 4 is in both sets, so I'm going to put it in here. Okay, it's inside C and it's inside B. 5 is inside C, but not B. Oh, I missed 3. 3 is not in either of them, it's going to live out here. And 6 is in both of them. Okay, so this is kind of a visual representation of these sets. If I have a look here, the intersection we said was the set of 4 and 6. In our diagram, it's the region in here that's overlapping. In fact, I might highlight that in here. It's the region containing B and C. That's the intersection. If we have a look at what the union is all of the sets that are in either of these bubbles. So it's a bit harder to mark out, but it would be this whole blob here. The combination of B and C is the union. Okay, 2, 4, 5, 6. Those are the numbers in the union. So these are a couple of important terms that we need to be aware of when we're working with sets. Finally, just a couple of comments about what we call the empty set. If I consider these two sets, one is the set 1, 2, 3, the other is the set containing 5, 6. The union of these two sets, remember, is the combination of the two if we combine them together. In this case, I would get 1, 2, 3, 5, 6 as my set. If I think about the intersection of these two, in fact, we don't have anything overlapping. Okay, there's nothing in set A that is also in set B. So in this case, we could represent it like this, as just 2 curly brackets with nothing in between. Now that looks a bit weird, so we do actually have a symbol to represent that. It's this symbol here, phi, the Greek letter. The reason we choose this is it kind of looks like a 0 with kind of a line through it. It's the empty set. It's the set not containing anything, and that is allowed for a set. You can have an empty set, a set that doesn't have anything within it. So that's how we define sets. In the next video, we're going to talk about how we're going to apply these ideas of sets to the definitions of probability that we learned in high school.